Inserting model assumptions. The company's best estimates on when it is ready to launch its products are shown on the following quarter table. This means that, for example, Product 1's launch date has been estimated between quarter 1 and 2. Product 5, the last one on the pipeline, has been estimated to be ready at some point between quarters 10 and 14. 1. On cell D3 we will insert a distribution function that generates evenly distributed random numbers within a discrete range, a uniform distribution. This distribution requires only two parameters, a minimum and a maximum value. Place your cursor on D3 and click on the Define Distributions icon of *Risks ribbon. 2. Go to the Discrete tab and select the int Uniform Distribution. 3. Using the Assign Excel References as Arguments button, respectively select the cells B3 and C3 as minimum and maximum values. 4. When done, click on the upper right-hand side corner of this dialog to return to the previous window. The following int uniform distribution appears. The uniform height of all the points between the minimum and the maximum implies that all possible outcomes within the range enjoy the same probability of occurrence. In this case, only two integer outcomes are possible between the 1 and the 2. The uniform distribution and its variance, such as the int uniform and the d uniform, is often called the no-clue distribution. When there is too much uncertainty and very little information about the central outcomes of any given phenomenon, a uniform distribution is a good starting point to define uncertainty. 5. Click OK to finish the insertion of this function, which should now look like this. Equals risk int uniform, B3, C3. 6. Copy and paste this function down to the range D3:D7. 7. If you were to open the function on cell D7 with defined distributions, it would look like this. This means that Product 5 could be launched on any given quarter between the 10th and the 14th, with the same probability of occurrence. If the dice icon is on, then, by keying F9 for recalculation, you will see how random numbers are generated for the potential integer outcomes on column D. Experts' opinion has also been gathered with respect to the initial sales amount for the first quarter of each product. For example, in the first quarter on which Product 1 will be sold, the most likely estimate will be to sell 80 units. This number could go as low as 50 or as high as 120. When no historic data exists, and an expert is able to reasonably estimate a most likely quantity and two extreme minimum and maximum points, a PERT distribution is probably one of the best choices. 8. Place your cursor on cell H3 and select Define Distribution on *Risks ribbon. 9. Go to the Common tab. 10. Double-click on the PERT distribution to select it. 11. Using the Assign Excel References as Arguments button, respectively select the cells E3, F3, and G3, as minimum, most likely, and maximum values. 12. When done, click on the upper right-hand side corner of this dialog to return to the previous window. The following PERT distribution appears. 13. Copy and paste this function down to the range H3:H7. Based on experts' opinion, the duration, in quarters, for stage 1 has been laid out on the following table. This means that the expert considers, for example, for Product 1, that its first growth stage will last an average of 6 quarters. Remember that this model considers 2 growth stages for each product. The first one is characterized by high growth rates as the technology enters the market and innovation is accepted. The second stage features slower growth rates of an organic nature. Since we have only one parameter characterizing the mean and duration, a discrete variable that only assumes positive values, we could use a Poisson distribution. 14. On cell J3, click the Define Distribution icon on top of *Risks ribbon and select the Poisson distribution out of the first Common tab. 15. Using the Assign Excel References as Arguments button, select the cell I3 for lambda, the single parameter required for a Poisson distribution, that represents the mean and the variance of the variable. 16. When done, click on the upper right-hand side corner of this dialog to return to the previous window. The following Poisson distribution appears. Observe that a Poisson distribution only generates positive discrete numbers, averaging on 6, the lambda parameter value. The standard deviation, 2.449, will also yield 6 when squared. A Poisson distribution also generates an infinite positive maximum with rapidly decreasing probabilities. 17. Copy and paste this function down to the range J3:J7. Observe that the expert has also estimated parameters for the 2 stages growth rates, shown on the following table. For example, the expert has estimated, for Product 1, that during the first growth stage, sales will most likely grow by 10% with respect to the previous quarter. These growth rates could be as low as 5% and as high as 15%. For the second stage, quarterly sales will most likely grow by 2% with respect to the previous quarter, but these growth rates could be as low as 1% and as high as 3%. 18. On cell Q3, insert the following function to calculate the quarter where stage 2 begins, equals D3 plus J3. 19. Copy and paste this cell down for the whole range Q3:Q7. 20. Fill R3:R7 with ones. We will use this range later on to select specific sales forecasts on which we want to focus.